Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Fred Schenkelberg.
And this is Chris Jackson. We're going to be talking about Weibull analysis and how you first, I suppose, dip your toes into Weibull analysis.
Yeah, I got a question a couple of days ago, and it was, I've been asked to, take a look at some field data, and I've heard about Weibull analysis, but where do I go to get started with this? How do I do this? What are the resources to get up to speed on this? There's a lot of resources out there, some better than others.
Right.
So naturally, I sent him to one of your webinars about what is Weibull analysis, yes, and then a handful of other articles that went into some more of the details. But it was, my first inkling and immediately shot down was to say, "Oh, go get some software and just plug it in there." And I think that's just, it would be a disservice to tell somebody, "Oh, just go find a package, or even online free package somewhere and just drop your numbers in there and it'll do the analysis for you." I think that's irresponsible.
Yeah, it's like driving a car without a license.
Well, driving a car having never seen one ever before.
Yep. Or maybe driving a car after you've studied what a car does on Wikipedia and understand that the accelerator makes it go forward and the brake stops it, the steering wheel controls left to right, because technically
that's all you need to know.
Yep.
Well, I use the bicycle instead of a car, is that, yeah, you could watch YouTube videos all day long about how to ride a bicycle, but you're still going to fall off.
Right.
So I think it was, well, here's the concept. I think that's what your webinar did really well. It's like, this is the concept here. This is what we're trying to do. This is why we do it. Stuff like that, kind of the fundamentals of it. And then the software helps you do the math, but you don't really need, I didn't go so far as to say, well, here's how you do it manually, which I don't know that I have a good article that talks about that. But the idea is that, well, what is it you're trying to do? Was the second part of it. There's Weibull analysis is just a tool. Is that what you need? Is that what you're trying to do? It might be fine just to do a simple Pareto, or not a Pareto, but a PDF plot. Just do a histogram. It might be sufficient for what you need.
Mm-hmm.
But if you need to find out what alpha and beta is, then you need to do some regression analysis. And how's your math skills with regression?
Yeah. So, I mean, again, we harp on a lot, what decision are you trying to inform, or what question are you trying to answer? But I suppose if people are just, in a very general sense, maybe moving towards reliability engineering as a discipline, they are aware that Weibull analysis it appears to be an important part of it. I can understand why people might ask, what's this Weibull analysis stuff, without me having a specific question or decision to inform.
Yeah, no, I get that. And that's kind of where I sent, 5 or 6 pieces of content and said, here's a place to start. And then, if you got questions, let us know. And then there's a handful of books and, other resources, and hopefully someday a course from you on it. Then we'll get, there's more of a sequence for that, but it's because if you ask that question at Reliasoft, they'd say, "Oh, here, buy Weibull++, and you're all good. We have a bunch of help pages on how to use it." And I'm like, no, that's, it's not akin to it's akin to getting on that bicycle, having only seen it on YouTube before. So that's why I appreciated the way you brought it up in the webinar. But I think it's the right thing to do. Is what is this stuff, and what do I need to know to use it, and how do I get started? And I think at some point is you got to get on the bicycle, take some data and run it.
Yeah.
But use a set of data that the answer for. Use it right out of a book where there's an answer. Run examples. and see what works and what doesn't work, and how do you interpret it, and get some feel for it before you drop in your real data and try to interpret that. I think that might be an idea, Chris, is let's create 10 data sets and say, all right, now go do, Weibull plots for this. Go do some CDFs or some PDFs or whatever, different data sets for different purposes. But what's the interpretation of these, and why does this data set show up that way? Those kinds of things. Like, think of when you're looking at a data set and the measurements are not gradated enough so that you get 100 data points, but there's 10 at point 1, and there's 10 at point 10, and there's 10 at point 20, and so on, where in order to understand what the curve there's not enough separation. It's all clumped together in these little discrete points. That's not enough discrete points to be useful. You learn that by, why does this look so weird? But I think part of it is you have to understand, well, what typical looks like. If it's truly a Weibull distribution data set, and it's not truncated, it's not two different failure mechanisms, if it's not, bad measurement techniques, or it's got a bunch of weird artifacts in it. If you don't recognize what those look like, then, and I saw one of these a couple of weeks ago, working with a team that's trying to come up to speed with dealing with their field data. And the data points were kind of a cloud in the middle of their plot. And they drew a line through it and said, all right, now looks like we have an increasing failure rate. It's like, well, you could draw about any line whatsoever through that mess and
Right.
come up with a different conclusion. But just because the software says that one's slightly, an upward trend to it, look at the data.
Absolutely. I mean, I think at the end of the day, Weibull analysis, I mean, most data analysis techniques at its heart, especially the good ones, which are able to visualize stuff, they sort of bridge the gap between numbers in a spreadsheet and a visual pattern that human beings are pretty good at recognizing.
Mm-hmm.
We recognize straight lines, you can recognize curves, you can recognize where a straight line has a corner or an elbow and goes to another straight line. We're really good at that, actually extraordinarily good at that. Computers aren't even close to what we can do with a millisecond glance at something.
Yeah.
So that said, what we're good at recognizing is patterns. And so Weibull analysis sort of meets us in the middle. It turns those numbers into patterns. And when you learn how to do Weibull analysis, you learn what certain patterns mean. And a lot of people have, you can't see my air quotation marks, but learned Weibull analysis without having any idea what those patterns represent. And that might sound like some sort of stuff the old professor saying there's so much more you can do. We should really do this to the nth degree, but that's not the point. In fact, when those Weibull analysis courses that we're sort of referring to as we roll our eyes, they're full of equations, they're full of sort of information.
Oh, also the examples are
factoids.
all the drawings or the examples are all perfect data.
Right.
Artificially smoothed out to be a nice, clean, smooth line, and to represent that particular distribution. And I've rarely ever saw, in doing like the early data sets in a CDF plot, in my experience, have been below the line always. And talking to other statisticians and so on, if I got 1,000 data points and I got 10 points that are well below the line over there, and they're like, "Yep, that's as good as it gets." And there's artifacts because of the logarithmic scale that's being used on the time axis. Is that those early points, have a big chunk of graph they have to cover, and then we have delays in getting it shipped from when it actually fails. It's different failure mechanism oftentimes. It's all kinds of artifacts that go into it. So some things you look at and go, oh yeah, that's typical. And there's reasons for it. And others you go, I have no idea what that is, but the software says that's a line, so I'm going to use that line.
Right. And I think Well, if those people who are listening to us saying, "Hey, you got to learn more about Weibull analysis," that sounds like more work. Well, it might not actually be, because if you learn about what to look for in those patterns, you might be able to look at a pattern and straight away say, oh, "Okay, that's what I need to service this system," just by working out where that corner in that line is.
Hmm.
Now, if you go to textbooks and how lots of other people would like to teach you how to do it, well, you have a fifth order differential equation, this multi-optimization problem, that, so on and
Oh, and
so
you got to
forth.
fit three different distributions and let the software do the breakpoints and
Right.
fit three different curves to it for you. And like, why?
But
I, I don't need to do that if I know that it changes here and I can fix it before that.
right, exactly. And so you might be able to look at the pattern and convert 10 years worth of misery, analytical misery, into oh, there it is. That's what we'll do. But yeah, so I suppose in a nutshell, if people are trying to understand what Weibull analysis is, it's a way of converting data points / numbers in a spreadsheet, usually time to failure, into a pattern where we can teach ourselves what that pattern represents and know what to look for and make really key observations that include you can look at a pattern in a Weibull plot, and it's feasible to work out, for example, percentage of things that are experiencing infant mortality, or where you should service / replace a part before it starts to wear out, or what its warranty reliability
It's my expected
is.
failures for next month, for example. Yeah,
Right.
you
Or
can.
if you have, hey, the warranty reliability needs to be 95%, what's our warranty period? And it might impress people to know that you can do all that based on patterns and not equations if you know how to do it. Just
Yep.
simply drawing lines on a hypothetical piece of paper,
Yep.
which will be on a computer screen, so it won't be actual lines on a paper, but hopefully the points
Well, I
being
used to
made.
do it on actual lines on paper.
Yeah, you can print it out and have fun.
Well, no, it was when I learned this stuff, it was Weibull plotting paper.
Oh yeah,
And
there's that.
there's a team was a printing house that made log normal plotting paper, Weibull plotting paper. We'd had a whole locker full of all these specialized distribution plotting papers, and we'd work out the points, what's the vertical axis, the PDF or CDF values for these things, and then
Hmm.
we'd sit down and plot them. And the guideline I got from my graduate school regression analysis class was, well, if the data points kind of fit under a number two pencil on an 8.5 by 11 piece of paper, it's probably pretty good fit. You know, it's like you don't learn that when you sit down with a piece of software.
Absolutely. And yeah, and my a lot of Weibull analysis courses are actually given by software companies masquerading as training organizations.
Yep. Some are better than others, although it's been a
Definitely.
while since the ones that I knew were good have even offered training that I know of. So it's varied a lot. Oh, I heard yet another software company got purchased and is getting absorbed into some other bigger company. Item Software has been
Okay.
purchased. So I don't know of any major reliability software houses that are independent anymore.
Right.
So it's you got to do it yourself. Get Python, get busy, R, stuff like that.
All matter.
Yeah, we shouldn't probably mention that. If you really want to learn regression analysis or Weibull analysis, is you got to learn how to code and find all the good libraries and do it yourself.
I forget which tech companies, and I think it's multiple, have essentially decreed that their employees need to know, I'm going to say Python, which is free, which is good. And
Mhm.
so, unless you can do it on Python, don't do it. I mean, you are, there is an art to making coding simplistic and elegant. It's really easy to make complex code.
Yeah,
It's really hard to make it simple and elegant and less likely to fail.
yeah,
So I'm aware of a couple of companies which have said, hey, if you're going to do anything, create your own stuff, you're using Python. We're not getting licenses for some of the bigger ones. I use MATLAB because it allows me to create videos of statistical stuff, which is the main
yeah.
reason I use it.
Is that the random hand of chance? Is that a
Yeah,
method?
all those. Yes, I got like a 10,000 cut line of code program I wrote in MATLAB behind that stuff.
Oh wow. No wonder you use
Yeah,
it all the time.
yeah, I got to get my money's worth out of it now.
Yeah.
But Python can't do that.
There is a time and place where you got to use, coding and everything else, but but like back to this question is that until
Hmm.
you kind of get what you're trying to do, and if you had no background in statistics or regression analysis classes or all the, you know, fundamentals of, well, what does it mean that when I have a data set and I'm trying to find the pattern for it, that does take some time. It doesn't take a lot of time. It's just explore it. It's play with the formulas, play with the fittings, use different data sets and say what if. Um, but the real danger is take your data set and you've got to make $1 million decision next week and present your results and you just plot whatever you got and aren't even aware of the underlying assumptions there. And I had that happen once where a guy was trying to predict how soon before the school district needed to build another building, build another uh, grade school. And
Hmm.
so he had this up and down pattern over the last 40 years in town. And it was just like a oscillating curve, time series type thing that every 5 years it would go up and then it would go back down and up and down. And it was in a very gentle glide slope if you put a line through the middle of all these oscillations. So he says, I didn't know how to handle this. So I took the last 3 years worth of data, which happened to be pointing almost straight up. And he drew a line straight up and said, we need a new school like yesterday. And I didn't know a whole lot about time series analysis. And it happened to be a class I was just starting at school. And I said, you want to hold that thought here. What if it's this line instead of the last 3 points? We just draw a line through the middle of it. And he said, well, I don't know how to do that. And I said, here. And it was this is a long time ago. It was on a plastic foil on an overhead projector. And I said, give me your pen
Hmm.
here. That's a way better estimate than what you just did. And the school board looked at it and like, I'm going to go with what Fred said. So we don't need to build a new school here for another 20 years.
There
And,
you go. It's pretty cool.
but sometimes it's just, you got to use a bit of common sense
You
in
do.
interpreting these patterns and not being limited by what you can and can't do. Yeah, you're going to go learn some new techniques. And sometimes you need a fancier package or a better analysis, but you can get a long way. I think the way you say it, Chris, is with just recognize the patterns and play with some. And I think that's actually a pretty decent idea. We should come up with 5 or 10 different data sets that you just go play with and and come back and say, well, what's the interpretation of it? And then if you got it right or not, then you get a point. Not worth anything, but you get a point. That's always useful. Um, that might be an interesting project. But anyway, if you're looking at a stack of data and wondering what to do with it, hopefully this gives you some pointers. Yeah, it's going to take some research and learning and try different things and explore it and play with it. But the idea is that you're looking for patterns, and some patterns are good and some patterns are bad. And we can, if you've got questions on that, let us know. And until we get these things built out and make some cool courses for you.
Hmm.
But if you've got a question like this or a different kind of question or whatever you're working with or struggling with, let us know. We enjoy hearing from you. Try to get you an answer back that's useful right away. And sometimes it turns into a podcast like this one. So let us know. Head over to accendoreliability.com/go /SOR. And there's a couple of ways to get in touch with us. Chris and I and the other hosts are available through LinkedIn and our about pages. Plenty of ways for you to get in touch. And we look forward to your questions. And good luck with your whatever types of analysis you're working on or trying to learn.
So always, but start with a decision.
That's right. What are you trying to do?
Yep.
Yeah. As opposed to that might be a whole nother podcast, Chris. Don't start with the answer that you want and then go
Right.
find an analysis to justify that. There's a whole different problem with that.
Seen plenty of those.
Yep, same. All right, cool. Thanks, Chris. We'll talk to you soon.
Always a pleasure.
Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.